A very warm welcome. In this video, we will cover stratification, which is one of the 7 QC tools. What is stratification? Strata means categories. Sampling is done category-wise, hence called as stratification. It is a sampling methodology, hence also called as stratified sampling. Prior to understanding stratified sampling, let's understand the difference between random and stratified sampling. In random sampling, samples are collected randomly, as its name also denotes. In stratified sampling, samples are collected category-wise. In random sampling, each of the sample has equal probability, that is, equal chance of getting selected. In stratified sampling, more samples are selected from the categories having large population size. Now, let's look at the steps that can be followed in stratification. We will look at those steps using an example. Let's take an example of exit poll, that is to check opinion of people regarding an election candidate, to check probability of winning the election. Now let's understand the steps. The first step in stratification is to determine the sample size. Let's assume that we decided to collect the opinion of 100 people for the exit poll to predict election results. This sample size is determined based on our budget, accuracy required, feasibility, time taken, etc. The second step is to determine the strata. Let's assume the candidate is standing for a district-level election for X position. So, we would be interested in knowing what is his or her chance of winning in this district. However, if we take the 100 samples randomly throughout the state, it might happen that we take more samples from low-populated cities and fewer samples from highly populated cities. Hence, we are interested in taking more samples from highly populated cities and less samples from less populated cities to get the actual picture. Let's assume the cities are named as A, B, C up to J. These are our strata, that is categories. Next step is to determine the strata size, that is population of these cities. Fourth step is to calculate the total population by calculating total of all strata sizes, which is total population of the district in our example. We will use this total for further calculation. Fifth step is to calculate percent contribution of each of the strata. For determining percent contribution, we will divide the strata size by total population, that is, total of all strata sizes. For example, for strata A, we will divide its size, that is 170,000 by 1,983,000. We will get an answer of around 8.57%. This means city A contributes to 8.57% population of the district. Similar way, we will calculate percent contribution of each of the strata. These are the answers we will get after calculation. Step 6 is to determine the sample size, that is, samples to be collected from each of the strata. The strata are cities as per our example. To calculate sample sizes, we need to multiply the percent contribution by total sample size. For example, 8.57% was the percent contribution of strata A, that is, city A's population contribution in the district. We will multiply it by 100, since the sample size we determined is 100. We will get the result as 8.57. But we will round up this number and outcome would be 9. Roundup is required since we cannot sample 8.57 people. We can either ask 8 people about their opinion or 9 people, and since the 8.57 number more close to 9, we selected 9. Similar way we can calculate the sample size for each of the strata. If we take some of the sample sizes we just calculated, it comes around 101, which is because of decimal values. Since our initial sample size selected was 100, we can either increase the budget to 101 or reduce the sample size of one or more of the strata. Here, reducing the sample size of strata F from 21 to 20 seems fine, since we are taking 20 samples, which are still high enough we consider the sample size of other strata. Thank you so much for watching this video. If you like the content, please like, subscribe and hit the bell icon to get regular updates.